Regents Review number 3. We're going to start with number 21. It's not in order again. Sorry about that, but it's just the way that this arranges it, and I can't arrange it correctly. An astronaut drops a rock off the edge of a cliff on the moon. The distance, d of t, in meters, the rock travels after t seconds can be modeled by the function d of t is equal to 0.8 t squared. What is the average speed in meters per second of the rock between 5 and 10 seconds after it was dropped? So the first thing we need to do is substitute this value in for t, get those two values, and find the average speed. So that's a formula. It's the change of y over the change of x. So d of 5 is equal to 0.85 squared. And d of 10 is equal to 0.8 times 10 squared. Number 23. In 2013, the United States Postal Service charged 46 cents to mail a letter weighing up to 1 ounce, and 20 cents per ounce for each additional ounce. Which function would determine the cost in dollars, C of z, of mailing a letter weighing z ounces, where z is an integer greater than 1? So 46 cents is the standard cost of a letter weighing up to 1 ounce. Anything over that, and we don't know what that value is going to be, you're always going to multiply 20 cents times z, the variable of each additional ounce. So the only one that represents that, it appears as though it is choice 2. Number 19. Miriam and Jessica are growing bacteria in a laboratory. Miriam uses the growth function f of t is equal to n raised to the 2t power, while Jessica uses the function g of t is equal to n raised to the 4t power, where n represents the initial number of bacteria and t is the time in hours. If Miriam starts with 16 bacteria, how many bacteria should Jessica start with to achieve the same growth over time? So in this case, I would do some substitution and just kind of guess and check to figure this out. So we know that Miriam starts with 16 bacteria, and this is her function. Another question is, how many bacteria should Jessica start with? Okay, the way to approach this problem is to, as I said earlier, is to do some substitution. And we know that Miriam started with 16 bacteria, and you see that I ended up with this. This is Miriam. You can represent 16, this value right here, in terms of a base and an exponent. So 2 raised to the 4th power, as you see here, is 16, and that is raised to the 2t power. So I translated that down here, or transferred it down there. And Then you multiply these two, because a power raised to a power you multiply, and I ended up with 2 raised to the 8t. So I needed to get something that yields the same value right here. And I did substitute all these values here. So I started out with 32, the first choice, and here's my 32 right here. You can represent that in terms of base 2 raised to the 5th power. That was raised to this 4t power. So I multiplied the 5 and the 4 and I ended up with 20t. So this one didn't work, choice 1. Then I moved on to 16, which is to the left here. So 16 is right here. I can represent that as 2 to the 4th, as we saw earlier. I multiplied it to the exponent of 4t right here, and then I multiplied the 2 and then I wrote it down here. So 2 raised to the 16t, that's too much, I needed 8t. So as you can see, I did the same thing here. I represented 8, which was choice 3, as 2 cubed, multiplied these two, got 12t, and that's too high. And then our final one, choice 4, is 4. Base was 4. So I rewrote it in terms of base 2, which is the most basic base for this. 2 squared is equal to 4. And I raised it to the 4t power. You multiply the exponents and get 8t. So 2 to the 8t is where I'm going to have the exact same value. So this is my choice. Number 20, if a sequence is defined recursively, important information there, you're going to use the value of the last term, by f of 0 is equal to 2, so that's your starting value, and f of n plus 1, that means the value of the next term, is equal to negative 2, f of n plus 3, for n is greater than or equal to 0, then f of 2 is equal to. So we have the value of f of 0, so the next value is going to be f of 1 is equal to negative 2, take the value of the given term, or the previous term, and add 3. So I'm substituting this into the equation. So f of 1 is equal to negative 4 plus 3, which is negative 1. Then we have f of 2 is equal to negative 2 times the last value plus 3, and we get positive 2 plus 3, which is equal to 5. Number 18, two functions y is equal to the absolute value of x minus 3 and 3x plus 3y is equal to 27 are graphed on the same set of axes. Which statement is true about the solution to the system of equations? The first thing you need to do is recognize that you have an absolute value equation right here. That's with the bars to the left and to the right. And this is a linear equation, so you need to solve this for y. So I'm going to rewrite it up here in order to do that. I'm going to subtract 3x from both sides. I get 3y minus 27, or equal to 27 minus 3x. And I'm going to divide out the 3. And then my new equation, or equation in terms of y, is 9 minus x. So if you go ahead and graph both of these functions into your graphing calculator, you will be able to answer some of these questions, answer the question, which is which statement is true. So I see I get a v and I see I get the line, and it intersects each other in one spot at 6, 3. If you look at the table, Control T, you'll see that 6 is your value for x, and you'll see 3 repeated twice for the two equations. So it satisfies both equations, so that is the solution. Choice 3. Number 24, a polynomial function contains the factors x, x minus 2, and x plus 2. Which graph or graphs below could represent the graph of the function? Well, you have to remember that a polynomial function that contains factors is set equal to 0. And when you set factors equal to 0, sometimes they are equal to 0, like this one, but then sometimes you have to solve for 0, so you're going to have to add or subtract numbers using inverse operations to get the opposite values. And then for x plus 5 is equal to 0, we know that x is equal to a negative 5. So we have three values, 0, 2, and negative 5. Okay, so 1 looks like it works, 2 does not, and neither does 3. So 1 only. Connor wants to attend the town carnival. This is number 13, by the way. The price of admission to the carnival is $4.50, and each ride costs an additional 79 cents. Right off the bat, I know that's going to be multiplied to the variable because you don't know how many rides you're going to take. It all depends to see what the final cost is. But this is a standard fee, so you pay that one time, you go in, that's it. If he can spend at most $16, so he can spend at most $16 is $16 or less. So he can do that at the carnival. Which inequality can be used to solve for r, the number of rides Connor can go on, and what is the maximum number of rides he can go on? Okay, so instead of x, we've got r. So let me go ahead and change that. So 79 cents times r. So immediately I can take 1 and 2 off. 3 and 4 qualify. So I'm going to solve this as though it were an equation, but I'm going to get an inequality and the maximum number of rides that he can go on. So I have to think about what the potential answer could be. So subtract 450 from both sides, just like you would with an equation, and get a difference of 1150. Drop the 0.79r, divide out the 0.79r, and get r is less than or equal to 14.56. So the maximum number of rides, maximum is the key term, is 14, because if he bumps it up to 15, he's gonna go over his budget of $16. So the answer is choice 3. So basically you're rounding down due to the inequality. Number 14. Corinne is planning a beach vacation in July and is analyzing the daily high temperatures for her potential destination. She would like to choose a destination with a high median temperature and a small interquartile range. She constructed box plots shown in the diagram below. Interquartile range, in order to find that, is Q3 minus Q1. And don't forget, in order to find the range, that is the maximum number minus the minimum number. I thought I'd throw that in even though you don't need that here. You never know what kind of question you could be asked on the Regents. Median is middle number. So, which destination has a median temperature above 80 and a smallest interquartile range? So the medians above 80 are Pelican Beach and Whispering Pines. If we evaluate the quartiles, we're going to see which one has the smallest. Okay, Whispering Palms. I think I'm going to have to expand that to see what that could be. It's about 94-ish. Minus 82, let's say. And then for Pelican Beach, we have 87-ish minus 83-ish. So it looks like a difference of 4 there for Pelican Beach. It looks like a difference of 12 for Whispering Palms. So the winner chicken dinner is Pelican Beach. And that, my friends, is choice 4. Okay, number 15. Some banks charge a fee on savings accounts that are left inactive for an extended period of time. The equation y is equal to 500 times the base of 0.98 raised to t represents the value y of one account that was left inactive for a period of x years. What is the y-intercept of this equation and what does it represent? So this represents an exponential equation, and how we know that is because we have the variable in the exponent, so you should recognize that right off the bat. So what is the y-intercept of the equation and what does it represent? Well, what I would do is graph this on a graphing calculator and take a look at where it hits the y-axis. So go ahead and do that now. So when you went ahead and graphed, you probably didn't see a graph, right? If you took a look at your table of contents, you would have noticed that your y values were extremely large. So I see 5,000 here. I just picked that number. I changed my window. So in my graph, I hit Menu, Windows, and changed the settings. And I expanded my Y max to 5,000, and I could see that's where the point of intersection is. And then you do a trace to just make sure, or you could change your table settings if you remember how to do that. You have to be in your table before you can do that. You hit Menu, Table Settings, Edit Settings, all that. And you could start your table at 5,000 or around there. So 5,000 is the amount of money in the account initially, and if you recall from one of the other review packets, I discussed these two things, this formula when it's plus or minus the rates. Basically, they already applied a rate, and there was a decrease because it's a number less than 1 in the set of parentheses. But the starting amount is 5,000. So we're not really interested in that at this time. Number 16. The equation for the volume of a cylinder is V is equal to pi r square h. The positive value of r in terms of h and V is, that means solve for r. Okay, use inverse operations in order to isolate r. So I'm going to rewrite this equation. And I see that I need to move everything else away from r squared at this point. So I see that pi and h are being multiplied to it. I'm going to divide it out. Very simple. So I'm going to rewrite my new part here. And this is all equal to r squared. And how do we reverse the process of squaring a number? Got to take the square root of both sides. So r is equal to v divided by pi h, which is number 1. Number 17, which equation has the same solution as x squared plus 6x minus 7 is equal to 0? Just looking at the format of this, the solutions is in terms of completing the square. So here we go. X squared plus 6x is equal to a positive 7. I got to add the 7 to both sides in completing the square. You're going to take 1/2 of 6 and square it. So that's 3 squared, which is 9. You're going to add that to both sides of the equation. Now you're going to represent this whole entire trinomial in terms of one factor. So it's x plus 3 squared is equal to the sum of 7 and 9, which is 16. Okay, and I see that here is choice 4. So I'm done. If you had to go further, the next step would be to take the square root of both sides, plus or minus the square root, that is, subtract 3, and that would be your final values for the solutions.